balked off the project, but Vishniac was a gentle and dedicated man. He decided instead to study the most Mars-like environment on this planet, the dry valleys of Antarctica, which were long thought to be lifeless. But Vishniac believed that if he could find microbes growing in these arid polar wastes, the chances of life on Mars would improve. So in November 1973, Vishniac was left in a remote valley in the Asgard Mountains of Antarctica. He set up hundreds of little sample collectors, simple versions of the Viking microbiology experiments. On December 10th, he left camp to retrieve some samples and never returned. He had wandered to an unexplored area, apparently slipped on the ice, and fell more than 100 meters. Maybe something had caught his eye, a likely habitat for microbes or a patch of green where none should be. The last entry in his notebook was Station 202 retrieved, 22:30 hours. Soil temperature minus 10 degrees, air temperature minus 16 degrees. It had been a typical summer temperature for Mars. Some of his soil samples were later returned, and Vishniac's colleagues discovered that there really is life in the dry valleys of Antarctica, that life is even more tenacious than we had imagined. That fact may turn out to be very important for the future history of Mars. There will be a time when Mars is thoroughly explored. What then? What should we do with Mars? If there is life on Mars, then I believe we should do nothing to disturb that life. Mars, then, belongs to the Martians, even if they are microbes. But suppose that Mars is in fact lifeless. Might we, in some sense, be able to live there, to somehow make Mars habitable like the Earth, to terraform another world? As lovely a world as Mars is, it poses certain problems for us. There's too little oxygen, no liquid water, and too much ultraviolet light. But all that could be solved if we could make more air. With higher atmospheric pressures, liquid water would become possible. With more oxygen, we might be able to breathe the atmosphere, and ozone could form to shield the surface from the solar ultraviolet light. The evidence for past liquid water suggests that Mars once had a denser atmosphere, which can't have all escaped to space. It has to be on the planet somewhere. In subsurface ice, surely, but most excessively in the present polar caps. To vaporize the ice caps, we must heat them, preferably by covering them with something dark to absorb more sunlight. That thing ought also to be cheap and able to make copies of itself. Well, there are such things. We call them plants. We would need to evolve by artificial selection and genetic engineering dark plants able to survive the severe Martian environment. Such plants could be seeded on the vast expanse of the Martian polar ice caps, taking root, spreading, giving off oxygen, darkening the surface, melting the ice, and releasing the ancient Martian atmosphere from its long captivity. We might even imagine a kind of Martian Johnny Appleseed, robot or human, roaming the frozen polar wastes in an endeavor which benefits only the generations to come. It might take hundreds or thousands of years. We might then want to carry the liberated water from the melting polar ice caps to the warmer equatorial regions. And there's a way to do it. We would build canals. But that's exactly what Percival Lowell believed was in fact happening on Mars in his time. The idea of a canal network built by Martians may turn out to be a kind of premonition. Because if the planet ever is terraformed, It'll be done by human beings whose permanent residence and planetary affiliation is Mars. The Martians will be us. Mars today is strictly relevant to the global environment of the Earth. Its antiseptic surface is a cautionary tale of what happens if you don't have an ozone layer. Its great dust storms and the resulting cooling of its surface played a role in the discovery of nuclear winter, the catastrophic climate change on Earth predicted to follow nuclear war. So if you didn't have an ounce of adventuresome spirit in you, it would still make sense to support the exploration of Mars. In recent years, there's been a groundswell of interest in organizing the first expedition of humans to go to the planet Mars. We first need more robotic missions, including rovers, balloons, and return sample missions, and more experience in long-duration spaceflight. But eventually, if all goes well, the interplanetary ship or ships would be constructed in Earth orbit, launched on the long journey to Mars, and then a landing module would set down on the surface. The crew would emerge, making the first human footfalls on another planet. It would be very expensive, of course, although cheaper if many nations share the cost. The key issue in my mind is whether the unmet needs down here on Earth should take priority. But that's a question even more appropriately addressed to the military budgets. Now, $1 trillion a year worldwide. You can buy a lot for that. Justifications for the Mars endeavor have been offered in terms of scientific exploration, developing technology, international cooperation, education, the environment. Some see it as the obvious response to the future calling. Some even think we should go to investigate enigmatic landforms, including one that resembles an enormous human face. Personally, I think this, like hundreds of other blocky mesas there, is sculpted by the high-speed winds, but if we're going anyway, there's no harm in taking a look. A remarkably diverse group of American leaders has endorsed the Mars goal. I imagine the emissaries from Earth, citizens of many nations, wandering down an ancient river valley on Mars, trying to understand how a quite Earth-like world was converted into a permanent ice age, and looking for signs of ancient life along the riverbanks. In the long run, the significance of such a mission is nothing less than the conversion of humanity into a multi-planet species.